Friends, today we'll be learning about pointer jumping and its application in finding the distance of a list's elements from its end. So we want to find the distance of all the list elements to their end. That is, 3 is at a distance of 1, 2, 3 from the end element, that is 8. So this is what we want to find for all the list elements. If we simply do this for all the elements, it will take O(n) time complexity for a single element, but we want to use a parallel algorithm using jump pointers, which will take O log n time. So this is the concept of pointer jumping. So what we do is we will try to explain this algo with an example. So initialize dis is representing the distance of that particular node from the end. So dis of last is equal to 0 because it is the last node. How it is identified? Because last ka next is equal to null. And all other dis initialize dis I with 1 for all other I. So here I have done the same. All other I have initialized by 1 and this one I have initialized with 0. Then for each list node n, in parallel we do this. If n dot next is not equal to null, we add dis n dot next to dis n and we move the next pointer to the next to next. So let's see in the example how we are doing this. So right now only one element is pointing to null. Okay, so we see that dis of, so for this element 6, we do dis of 6 which is equal to 1, we update it to dis of 6 is equal to dis of 6 plus dis of its n dot next, that is dis of 8. So dis of 6 becomes 1 plus 0, that is 1. All other values are also updated like this. So dis of 4 becomes dis of 4 plus dis of 6, that is 1 plus 1, that is 2. So similarly I have updated all of them. And now instead of pointing to the just next element, I am pointing to my next to next element. So you can see the list has been divided into two halves, the even elements and the odd numbered elements in a single iteration. Then we repeat the iteration. We do these two steps. Dis of n is equal to dis of n plus dis of n dot next, and n dot next is now pointing to n dot next dot next. So I update the dis values again, and this is done only if n dot next is not equal to null. Whatever is pointing to null is finalized. So in this case this is pointing to null, so this distance is finalized. So actually the distance of this element is 3, as you can see also 1, 2, 3. Okay, and in the fourth iteration everything is pointing to null, so every distance is finalized. 0, 1, 2, 3, 4, 5, 6, 7, all the distances have their actual values in the fourth iteration. So for 1, 2, 3 iteration of the algorithm we did. 1, 2 and 3. 4 are the number of states. So 3 iterations for 8 elements. 2 to the power 3 is equal to 8 elements. So for n elements, log n iterations are required. As we can see, initially there was only one element pointing to null. Then 2 elements were pointing to null. Then after the second iterations, 4 elements were pointing to null. After the third iteration, 8 elements were pointing to null. So after the n iteration, 2 power n elements will be pointing to null, and and whatever is pointing to null, whatever's next is pointing to null, its distance is finalized. Hence, in n iterations, we can make 2 power n elements to point to null, that is, their distance we can find. So, if we have n elements distance to be found, we can do them in log n iterations. And each iteration is taking a constant time on the parallel machines. So this algorithm complexity is log n. So hope you understood how we are proceeding with this. Thank you friends. Please like, share and subscribe.